Section 12.7, Spherical Geometry. Scan Lesson 12.7 lists two headings you would use to make an outline of this lesson. The first heading I see says Geometry on a Sphere. And the second would be comparing Euclidean and spherical geometries. Review. Match each term with its definition. An oblique cone is when the axis of the cone is not the altitude. It's leaning over. A right cone is when the axis of the cone is the altitude. It's standing straight up. A cross section is the intersection of a solid and a plane. It's when you cut that 3D figure and you open it up to see what shape is revealed. An isometric view is a corner view of a 3D figure on 2D paper. That's what we used isometric dot paper to draw. A regular pyramid is a figure with a base that is a regular polygon, meaning it has all congruent sides and all congruent angles, and the altitude has an endpoint that is the center of the base. And lastly, the slant height, represented by the cursive letter L, is the height of each lateral face of a regular pyramid. A pyramid is slanted, therefore it has a slant height. New vocab. Fill in each blank with the correct term or phrase. Spherical geometry is geometry where a plane is the surface of a sphere. A geometry where a plane is a flat surface made up of endpoints that extend indefinitely in all directions is known as Euclidean geometry. A type of geometry in which at least one of the postulates is from Euclidean geometry is known as non-Euclidean. So everything we've been studying before is not spherical geometry. We've either been in Euclidean or non-Euclidean geometry. So we've determined that a plane is a flat surface. We're now moving into one section talking about spherical geometry, where the plane is it's the entire surface of that sphere. Okay, so if we were doing Euclidean before, we had points, and points made lines, and lines made planes that extended indefinitely in all directions. This is what we're used to. Spherical geometry, if we start from a sphere, and that's our plane, then it means our lines are going to be great circles. Okay? So let's see. Use the diagram of the sphere below to answer each question. Name two lines, remember we're talking about on a sphere, containing point P. Well, if I look, point P is right here. Point P is contained in line FC. Okay, it's also contained in BE. Name a segment containing point Q. Well, segment has endpoints. How about BP? Name a triangle. Okay, a triangle has to be made up of three different lines. If we're talking about lines in terms of circles, okay, we're looking for things that are on three different circles. What if I start with B? That's on this circle here. Okay. What if I picked A? A would be on a different circle. And then we would need one more. How about F? Now, does BAF look like a triangle? Not necessarily, but a triangle has to be three intersecting lines. That's what we've talked about before. Well, circle containing B intersects circle containing A, and it intersects circle containing F. So it still fits our definition of a triangle. So let's continue to compare so you can see the differences between these two geometries. Euclidean geometry, a plane is a flat surface, whereas in spherical geometry, the plane is the spherical surface. In Euclidean, the shortest distance between 2 points is a line segment. Okay, the shortest distance between 2 points, well, if we're talking about a line, now we're moving to circles, and part of a circle we called an arc. Just like part of a line we called a segment, part of a circle we call an arc. In Euclidean geometry, a line is infinite. It goes on forever in both directions. But in spherical geometry, if we're talking about a circle as a line, that is not infinite, it is finite. Through any two given points, there is exactly one line passing through them. So if I have this point and this point, one line goes through them. Through any two given points, there's going to be one great circle passing through them. Remember, the great circle has to go through the center of the sphere. A unit used to measure a line could be a centimeter, an inch, feet, any of those work. Whereas degrees would be what we measure in spherical geometry because we're talking about circles. 2 points can be any distance apart because lines go on forever. Okay, we can go as far as we want apart. But if we're talking about a circle, the farthest distance you can be away in a circle would be 180 degrees. Otherwise, you're moving closer and closer either direction you go. So now you will work on section 12.7 assignment, comparing the two geometries and trying to rewrite them just like we did here. We had everything written in Euclidean and it was rewritten in spherical, or you will be naming the parts like we did here. And we'll go over any questions you have either on Zoom, or feel free